2 cosine I plus 2 sine t j plus tk.
Okay, and then it's from 0 to 4 pi inclusive.
From 0 to what?
4 pi.
Okay. So we have a plane, y equals negative x, and we have a curve, 2 cosine t, 2 sine t, where t goes from 0 to 4 pi, and we want to find where, if anywhere, those intersect. Okay. Do you have any ideas about how to start this, or any ideas that you've tried and didn't seem to work or anything like that?
I drew the plane.
Okay.
It's so y equals negative x. It looks like the y equals negative x on 2D scale, but in this case you're drawing 3D, so just
Okay.
adjust it for the z-axis.
Good. So y equals negative x
Yes.
in 2D would look like that. And then, since we're drawing the plane, it looks something like this. Good. And then how about that curve? Do you know what the curve looks like? You do x squared plus y squared here, what do you get?
4.
Good. 4 cosine squared plus 4 sine squared is just 4. And in 3 dimensions, this is a surface. What does that surface look like?
So
Good. It's a cylinder. So the circle of radius 2 sits something like this in the xy plane, and then the cylinder looks something like this. Not sure how I should draw it. So this curve, because x squared plus y squared equals 4, that means this curve sits on this cylinder. But look at what's happening to the t value. It starts at 0, and then it starts to go up as you go from t equals 0 up to t equals pi over 4. What do x and y do as t goes up from 0 to 4 pi?
they're the same.
What do you mean they're the same? What?
Well, the cylinder centered at 0, 0.
Okay.
So the radius is 2. So x intercept is negative 2, 2. Y intercept is negative 2, 2.
Let's see. So the x-intercept would be you plug in. Well, actually, there may not be an x-intercept or a y-intercept. It depends on
Yeah.
what's happening at t equals 0. Because z has to be 0 to get an x or y-intercept. So we actually do have an intercept at one of those. When t equals 0,
It's 2, 0.
2, 0, good. So we do have an intercept here. In fact, that's our starting point for the curve. That's good to know. And then what I'm trying to get at is, if this is a picture in 2 dimensions, as you let t go from 0 to 4 pi, and you're starting over here, what is the curve doing?
A circle.
Yeah, it's making a circle. It's wrapping counterclockwise. it goes around twice as we go up to 4 pi. So what does that tell us about our curve here in 3 dimensions? If this said z equals 0 instead of z equals t, what would this curve look like?
It would be a circle.
Yeah, good. It would just be this blue circle in the xy plane. Radius 2, centered at the origin. But, and it would wrap around from positive x-axis to positive y-axis, and it would wrap around twice. But as you wrap around, the t value, the z value is going up with t. So what happens is, as you start to wrap around to the y-axis, you start to go up. And then you keep going up. And you go around, so here I've gone around once, I need to go around twice. So it looks something like this. So that's the curve. How many times, John, do I expect that to hit the red plane now?
3 times?
Okay, so let's see. It looks like we're going to hit it once as we come to this back part. And then as we come back around, we should hit it again somewhere. And then as we come back here, we'll hit it again. And maybe we'll hit it again on this back side. I don't know where these red dots are exactly. 3 or 4 times. But we still haven't talked about how to actually calculate that. So all of this is sort of building up our intuition around the problem. How do I actually find out where those intersections are taking place? What's so special about these intersection points?
Oh, the z. Oh, the x and y are just reverse sign.
Yeah, good. What's special about these points is that they do satisfy this equation, but they also satisfy this equation. So we have, if we set y equal to negative x, then we should be able to solve for these points. Let's try that and see what we get. All right, there's y equals negative x. Any ideas on how to solve for that?
Just tan equals -1.
Okay, so it sounds like you're dividing both sides by -2 cosine t to get, I'll go ahead and write that. So on the right, you're getting negative tangent t, and on the left, you're getting 1. Okay, good. What are the values of t that make that true?
So 3,004. And 7
pi over 4.
Okay, good. So you said 3 pi over 4 and 7 pi over 4? Do you guys believe that? That tangent is equal to -1 at those 2 points? because the x and the y are the same except for one's positive and one's negative. Yeah, I believe that. So t is 3 pi over 4 or 7 pi over 4. Okay, that gives me two solutions. Do you think that these are the only two solutions?
I'll keep going up until
Yeah.
you hit the limit of 4 pi.
Yeah, good. Just remember, we need to go up to 4 pi, so we need to wrap around this twice. So if I wrap around one full time and then come back around, what's that value of t?
11 times 4.
Good. Good. I just need to add 2 pi to this, which is 8 pi over 4. And then same thing here. Good. These are the t values that should give me the intersection points. And now, what do I do to get the actual points themselves?
Just plug it in.
Good. Plug these in to this original R of t, and you get the 4 intersection points.